Gigi, the science geek.
Science rules!
Force is a push or a pull.
Whee!
Net force is the combination of all forces acting on an object. When more than one force is acting on an object, the net force determines the motion of the object. In this example, Gianna is not moving, so the net force is 0. The monkey bars are keeping her up, and gravity is pulling her down. She's hanging through the monkey bars. Kayla is there in case the gravity is too hard and she falls.
Balanced forces. When two or more forces are equally exerting force on an object. As you can see here, Stacy and Kayla are equally pushing on Angela, causing their forces to cancel each other out.
I'm not moving.
Which is why Angela's not moving. Unbalanced forces. When two or more forces are not exerting equal force on an object, causing that object to move. In this case, Kayla is shoving Angela more than Stacy, causing Angela to fall to the ground.
Newton's first law of motion. An object in motion will stay in motion unless acted upon by an outside force, and an object at rest will stay at rest unless acted upon by an outside force.
Kayla is in motion, and she is staying in motion until Stacy hits her. Stacy is the outside force. Time to go scare some geese.
Object at rest will stay at rest until an outside force acts upon it. In this example, Gianna kicks the ball and it rolls across the floor, from rest to motion.
Friction is the force that brings nearly everything to a stop. That's because this bad boy has brakes, which squeeze the tire, causing friction.
The type of friction that prevents an object from moving when a force is applied is called static friction. Static friction is caused by the attraction between the atoms on the two surfaces that are in contact. Gianna's pushing the water bottles, which are really heavy, but as she pushes harder and harder, it'll finally move. Static friction is due to the microscopic roughness of two surfaces. If you push an object across the room, you notice a sliding friction between the bottom of the object and the floor.
The sliding friction slows down this recycling bin that me and Angela are pushing. If there was no sliding friction, we would be able to move it as fast as we can when we carry it.
Rolling friction occurs between the ground and the part of the tire touching the ground, as you can see with Gianna. Rolling friction keeps the tire from slipping on the ground. If the scooter tires are rolling forward, rolling friction exerts the force on the tires that pushes the scooter forward.
Friction is the resistance caused by gas or liquid. In this case, as you can see, I will drop 2 rocks. The rocks that didn't go through the water hit the ground faster, and that's because the water caused the rock to slow down because of its resistance.
The second law of motion connects force, acceleration, and mass. According to the second law of motion, an object acted upon by a force will accelerate in the direction of the force. Here, Gianna throws the ball up and it's driven down by gravity. Poor Gianna. The acceleration is given by the following equation. Acceleration equals net force in newtons over mass in kilograms.
Eureka! How did that happen?
That was gravity.
My golly, what's gravity?
Gravity is a force that pulls things towards Earth's surface.
Really?
It is a force that pulls things towards the Earth's surface.
Weight is the gravitational force between you and the Earth.
My force is a lot, and quite frankly, I'm sick of it.
6 months later.
I'm fit and active, and I feel good. Thanks to Jenny Craig. Mass is the amount of matter in an object. Mass does not change, while weight does.
As she's rolling down the hill, she's accelerating. As she gets closer to the bottom, she's slowing down.
Ow!
And then she stops. Eventually. Sometime. Today, maybe?
If a net force acts at an angle to the direction an object is moving, the object will follow a curved path, like we see here with Stacy and Angela throwing the ball. As they throw it, the gravity pulls down the tennis ball, forming a parabola. Yay! Yay! Centripetal force will keep this water into this bucket.
Now you think it may fall out, but it won't, due to centripetal force.
Wait.
Centripetal force is otherwise known as circular motion. When you're in circular motion, you're constantly moving. Therefore, a force is acting on you at all times. Centripetal force is always perpendicular to the motion.
Whether you are walking, running, or swinging, air is pushing against you. This push is air resistance. Air resistance is a form of friction that acts to slow down any object moving in the air.
Otherwise known as drag.
Angela, on the left, is swinging faster than Gianna because she has an umbrella and the air is pushing back.
Newton's third law of motion. Forces always act in equal but opposite pairs. Basically, for every action, there is an equal but opposite reaction. As you can see here, Leanna is pushing on the wall, and the wall is pushing back on her. If the wall was not pushing back on her, she would fall through the wall because it was smushing, which is not, because of Newton's third law of motion. Action and reaction forces don't cancel each other out, like many people think they do. As you can see here, we've got basketball Wilson and basketball Rollins. And when they collide, they don't cancel each other out, even though they just bounce off each other, because they're both hitting on the opposite basketball, not on one.
Sometimes people don't notice action and reaction forces because one force tends to be so much larger than the other.
It has so much inertia or tendency to remain at rest that it hardly accelerates. Walking is a good example. When you walk forward, you push backward on the ground. Your shoe pushes earth backward. Earth pushes your shoe forward, and basically the earth doesn't move at all, as you can see Leanna exampling in her walking. As you can see, when I stand on the scale, I have weight. That's because the scale's force is pushing up on me, and my force is pushing down on the scale. Weightlessness is when you appear to have no weight. Now, when I jump in the air as I'm falling, I'm considered weightless. Now, I have this piece of paper, and it's representing a scale, because if I really had a scale, I might break something. But for these few seconds that I will be in the air, I will be weightless, because the scale's force will be pushing down, and so will mine. So there will be no force acting up upon me. That was weightlessness.
Gigi, the science geek.
I'd like chills to land that. Yeah, but the you recording?
You know what's that, but you're wasting our camera time.
Yeah.
Only like 11 seconds of it.
12.
10?
A lot.
30. 80.
Okay, so
Okay, cut.
did I say I was ready? Okay. So here we go. Yeah, friction. Friction is the force that brings nearly everything to stop. Okay? Capta? Understood? Do we know what friction is?
Get over here.
Do we know what friction is? That's good.
See this?
Friction is the force that brings nearly everything to stop.
What's up, friction? Oh, yellow.
Rolling friction occurs between the ground and the part of the tire touching the ground, as you can see with Gianna. Rolling friction keeps the tire from slipping on the ground. If the scooter tires are rolling forward, rolling friction exerts the force on the tires that pushes the scooter.
Angela screwed it up! Angela screwed it up!
Broke my...
Are you recording?
Yeah.
The music's staring at me. Still going.
Ah.
Next week on Gigi, the science geek, momentum.